hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is maximum side length of a square with sum less than or equal to threshold. So given a m cross n matrix mat and an integer threshold, we need to return the maximum side length of a square with sum less than or equal to this given threshold, or return 0 if there is no such square exist. So the problem is pretty much straightforward. So you are given a matrix mat and you need to find the maximum side of a square such that the sum of all the elements inside this particular square, so let's say this is the square, such that sum of all the elements inside this square should be less than equal to threshold. And whatever the square side of the square is, let's say the side of the square is k, so we need to find as max value of k as possible. So this is what the question is saying. So let us see the first example and try to understand the question in more better way. So this is the first example and the threshold given is 4, and this is the input matrix that they have given. Now you can see that there are two squares. This is the first square, its length is 2 or its side is 2, and the sum of elements inside is less than equal to threshold. So sum inside this square is 4, which is equal to this threshold. So this side is valid. Now this is also another square. Inside this also the sum is 4 and which is equal to threshold, and its side length is also 2. So yes, 2 is a side length which we have of a square such that all the elements sum inside is less than equal to threshold, and we cannot find any other square with greater side. You can see the side of square with side equal to 3 doesn't satisfy the condition. So in this the maximum side length we get is 2, so we will be returning 2, and that's why our output is also 2. So what can be the brute force way? So the brute force way can be to check all the possible k values of square, or let's say whatever the side we are taking, let's say the k is the side of the square. So let's say k is the side of the square. So for each and every side length, now what can be the range of this k? Range of this k can be from 1 till minimum of m comma n, because this is the side length which we can take maximum for a particular square within this matrix of size m cross n. So we can try out each and every possible square of length k cross k. First we'll be trying from 1 cross 1, then we'll be trying square length of 2 cross 2, then we'll be trying square of length 3 cross 3, so on and so forth. We can try out all the possible squares. Now within this particular matrix that they have given, let's say this is the matrix. So let's say currently our square side is 2, so we can create a square side starting from this point like this. Then we can create a we can create a square starting from this point like this. Then we can create a square starting from this point like this, again from this point like this, so on and so forth. We can try out each and every I comma j value for all the possible side length of a square. So for all the possible side length of a square, we can iterate over all I and j values with this I and j value to be the top left coordinate of the square. Now within this square we can again run a loop to compute the sum within this square. Within this square, and then after computing the square we can just check whether this particular sum is less than equal to the threshold or not. If it is equal to threshold, okay, we got this one side length which can be our possible answer. Now we can move on to the next k values, if we can get higher k value in future or not. So this is the brute force way, and obviously like there are too many computations, repeated computations. You can see the sum we are computing again and again, so we can optimize this a little bit more. So we have one better approach for this. So this was the brute force approach. Now we'll be looking at the better approach. Now better approach uses the concept of prefix sums in 2D. So prefix sums in 2D matrix. So I'll not go into much details, but yeah, I will show you how prefix sums are built in 2D matrix and how we can calculate a particular range sum for a given matrix. So let us see the better approach. So this will be the better approach. So in this brute force manner, what we were doing, we were computing sum for each and every square every time. So we were computing sum every time. Now what we can do, instead of computing this every time, we can just compute and store it in some prefix sums, and whenever we need sum of all elements inside the square, we can just use this prefix sum and get the sum of this all the elements inside the square in O of one time. So the better approach uses the prefix sums. So let us see how a prefix sum is built first. So this is the initial matrix that they have given, and we are building the prefix array. So first of all, the basic thing is we will fill the first column and we will fill the first row initially. That is how we build the prefix array in the 2D matrix. So I am just showing you the glimpse how prefix 2D prefix sums work. But yeah, so this is the initial step, filling the first row and filling the first column. Now we need to fill all of these elements. So now if you want to fill this element, what does this element say? This element says that I want to get the sum till here. So this element will store the sum of this part. So this is what this element particularly stores. Now how we can get the sum of this particular part? How we can get the sum of this part? Now this sum, to get this sum, what we actually need? We need to get the sum of 2 plus 1 plus 5 and obviously this element itself. So we want this element itself plus this 1 plus this 2 plus this 5. Then we can fill this particular part in this prefix sums or prefix matrix. Now we know that this 3 part already stores the sum of 1 plus 2. So we have solved the problem of 1 plus 2. We can get this from this particular above part or the top part. And we know that this sixth or this left part stores the sum of 1 plus 5. So we have actually solved the problem of 1 plus 5 also. So can't we just add matrix of I comma j plus this 3 or this top part plus this left part, or which is 5? Yes, we can do that, but wait, we have added this 1 here also in this 6 part. Sorry, this is 6 and yeah, this is 3. So we have added this 1 in this 6 part also, and we have added this 1 in this 3 part also. So we have added this 1 2 number of time. So no problem, just subtract it one more time. So what we can do, we can subtract this 1 or whatever this top left value is from our current result. So what we can say, to get this current or to fill this current element, what we can do, we can get this matrix of I comma j. Obviously this element will itself be included in the sum, and we will add prefix of I comma j minus 1. So what is I comma j minus 1? I comma j minus 1 is this part, and we can add I minus 1 comma j. So I minus 1 comma j is this. Now when we add I comma j minus 1 and I minus 1 comma j, we have already included this number 2 number of times. So we need to remove this particular number 1 number of time. And what is this number? If this is I comma j, so this is nothing but I minus 1 comma j minus 1. So we need to subtract prefix of I minus 1 comma j minus 1. So this is how we'll be building our prefix matrix or prefix sum matrix. So we have filled this part. Similarly, we will be filling this part, this part, this part, and we will be filling this entire prefix array matrix. Now after filling this matrix, our matrix would look something like this. Now we have built this prefix part, prefix sum part. Now how will we get the sum of particular square? So how to get sum of square? This is the main thing. This is what we need to do in O of one time. So let's say we need to compute the sum, or we need to get the sum of this yellow part. So let's say we need to get the sum of this particular part. So what we can do, first we need the top left coordinate of this particular square and bottom right coordinate of this cell. So let's say we name this top left cell as x1 comma y1 and we name this bottom right cell as x2 comma y2. Now first of all, what we can do, we can simply take this entire sum till here, till this bottom coordinate. So let us see what we are doing. So first of all, we will be taking this entire sum, the marked in yellow. So what is this sum? This sum is nothing but prefix of x2 comma y2. Now we have taken this entire sum, but we actually need this sum only. So what we can do, we can simply remove this blue part, we can simply remove this blue part, and we can simply remove this pink part from the current sum that we have. So to remove this blue part, what is this blue part? This blue part is nothing but this particular sum. So this is this part is x1 comma y1. So this is the top left cell and this is the bottom right cell. So and this is x2 comma y2. So we need to remove this blue part. So what we can do, we can just take this prefix sum of this value, because this prefix sum will store the sum of all values that we have till now. So what is this value? This value is nothing but x1 minus 1 comma y2. So we can subtract prefix of x1 minus 1 comma y2. Now we need to subtract this pink part. So how we can get the sum of this pink part? The sum of this pink part will be stored in this green part. So what is this green part? This green part is nothing but x2 comma y1 minus 1, because this is x2 and this is in the same row as of x2, and y1, this is y1, and we just need to go one column backwards. So this coordinate is nothing but x2 comma y1 minus 1. So we need to subtract this entire sum. So this sum is what? This sum is nothing but prefix of x2 comma y1 minus 1. Now again there is one problem. We have removed this entire pink part, we have removed this entire blue part, but wait, we have actually reduced this particular white part 2 number of time. So okay, no worries, we can add this one more time. Because we have subtracted this white part 2 number of time, we need to add this white part one more number of times so that we can balance it out. So what is this white part? This white part is carrying this sum till this particular part. So what is this coordinate? This coordinate is nothing but x1 minus 1 and y1 minus 1. Now this coordinate stores the sum of all these parts till here. So we can just add this prefix of x1 minus 1 and y1 minus 1. So that is what we are doing. So we are just adding prefix of x1 minus 1 comma y1 minus 1. So our final answer becomes what? So let me just show you. So our final answer becomes prefix of x2 y2 minus prefix of x1 minus 1 comma y2 minus prefix of x2 comma y1 minus 1 and plus prefix of x1 minus 1 comma y1 minus 1. So this is the basics of prefix sums that I have just told you here. But yeah, you can obviously first learn the prefix sums and then come. I have just given a basic glimpse of what prefix sums are and how it is made and how we can query it to get our answer in O of 1 time. So this was just the basic stuff that I have shown here. You can just watch some other YouTube tutorials as well. You can understand in more better way. But yeah, this is the basics of prefix sum that we'll be using in this particular question. So this is the optimized approach. So yes, in the brute force approach, we were computing for each and every square, we were iterating to the entire square and getting the sum of this entire square. But in the better approach, what we are doing, we are already pre-computing with the help of prefix sums, and now when we need to get the sum of square, we can just use this prefix sums and get the sum of square in O of 1 time. So this is the better approach. So what can be the most optimal approach? So let us see now. So let us discuss the most optimal approach. So let's say you have a side of square as length equal to 3. So this is the side of square. Now tell me one thing, if this particular square has sum of elements which is less than equal to threshold, what about the sides which is 1, 2, 3, 4 up till this value k? Now this side of length, this square of side k, if this particular square satisfies this sum condition, which is less than equal to threshold, then obviously these side length will also, which is lesser than k, will also satisfy this condition, because if the larger square satisfy the some condition, then obviously the lesser square sides will also satisfy the condition, because these square will contain less elements than this bigger square. So obviously these will obviously satisfy the condition. So let's say k is the square which satisfy the threshold. So from 1, 2, 3 up till k, these all satisfy the condition of threshold. Now let's say we are at k plus 1. Now this does not satisfy the condition. So let's say we are at k plus 1, or let's say the side of the square is k plus 1. Now this does not satisfy the condition. Now if this does not satisfy the condition, can you say that side of k plus 2 will satisfy the condition? This is the side of k plus 2. No, it will not satisfy the condition. Why? Because our matrix contains only positive elements. So there is no way that a square which is of side k plus 1, which is not satisfying the threshold condition, then k plus 2 side square will satisfy the condition. No, because here elements are added and all elements are positive. So no way, by adding more elements your sum will become less than equal to threshold, because all elements in the matrix are positive, not negative. If they were negative, we can say that okay, it might be possible that for smaller area our threshold condition doesn't satisfy, but for some bigger area it might satisfy, because it may contain all negative elements. But in this case we have all positive elements. So if we say that if k plus 1 square does not satisfy the threshold condition, then we can also say that from k plus 2, k plus 3 up till whatever the minimum of n comma m is, these will also not satisfy the threshold condition. So what we can say here? So up till 1 to k, all the values satisfy the threshold condition. Then k plus 2, k plus 3 up till minimum of m comma n, these will not satisfy the condition. Now just tell me, by looking at this particular thing, do you recognize anything? Now these are the k values. K is what we need to find the answer. And what are these things? This shows the monotonic character. This shows the monotonic character. Either till this part everything will be true, and after this part everything will be false. So this gives us the hint of binary search on answer. And what is answer? The answer is the k, or the side of the square that we need to find. So in the most optimal part, what we can do? What we were doing till the better approach, we were trying out all possible values of k, and for all the possible values of k, we were iterating on I comma j to check each and every possible square and compute the sum in O of 1 time using prefix sum. This was the better approach. We were iterating on all possible k. Now in the optimized approach, we will not iterate on all possible k. So in the optimal approach, we will not iterate on all possible k. Instead, we will use binary search. Let's say if for some particular k value, it satisfies the threshold condition, so we can increment our k towards the right side. And let's say if for some particular value of k, it does not satisfy the threshold condition, so we can move our k value towards the left side. So what we are doing, either we are completely ignoring the left half, or we are completely ignoring the right half. So that is what we are doing in the binary search approach. So in this optimal approach, what we are doing, we are already using the better approach prefix sum technique, and here we are adding binary search to it. So this optimal approach consists of prefix sum plus binary search. Prefix sum from the better approach and binary search that we have just seen till now. So this is the technique which we'll be using in our code to write this most optimal code. So I hope you understand this part. So let us directly see the code now. So yeah, this is the code. So first I am declaring two variables n and m, which is denoting the size of the matrix. So in the question it is given that the size of matrix is m cross n, but I prefer to use n cross m. So yes, n is the number of rows and m is the number of columns. Then I have declared a prefix matrix of size n cross m, initialized each and every value to 0. then I am initializing the 0 0 element of prefix to be matrix 0 0 element, and then we are first filling this first row and we are filling this first column, and on the basis of this first row and first column we'll be filling the other parts of this prefix sum. So starting from 1 till n for I and 1 till m for j, we are just filling the matrix in the drawing explanation part that we have seen. So we will take this current matrix element, then we will take this top element and we will add it to our current sum, and then we will add this left element to our current sum. But since there will be a common part which is added twice, so we will subtract this common part from our current sum. So this is how we are filling this particular prefix sum matrix. Then what we need to do, we need to binary search on answer on this k value or the side of the square that we have. So what we are doing, we are initializing a low value for 1 and high value for minimum of n comma n. Now this is why we are initializing it to minimum of n comma m, because let's say the matrix size is m and matrix size is n cross m. So even if the n value is 4 and m value is 3, you cannot create a square of more than 3 cross 3. So that's why we are taking the high value as minimum of n comma m, and we are initializing our answer to be 0, because if we do not find any answer, in the end we need to return 0. Now we are just using the binary search approach. So first we are calculating the mid value with the help of low plus high by 2, and we are declaring a variable found false. Now what is this found? Found is saying whether we found a square which satisfies the threshold condition or not. So initially it is false. If we find, we will just make it true. Now we are trying to make square for each and every I comma j as the top element of the square. So let's say this is the matrix and we are creating a square of side 2 cross 2. So first we'll be starting from here and we will create a square here. Then we'll be starting from here and creating a square here. Then we'll be starting from here and creating a square here, so on and so forth. Now we cannot start a square with here because this will go out of bound. So we are just keeping check of the out of bounds, so that we are within our limits. Now these I and j will be actually the top left coordinate, and this x2 and y2 will be the bottom right coordinate, because in the prefix sum part we have seen we need these two coordinates in order to get the square sum. So these are the top left and bottom right coordinate. Now if we have the top left and bottom right coordinate, we can simply get the sum of the current square with the help of this function. Now we will see what is this function, but yeah, whatever sum we get, we will check whether this is lesser than threshold or not. If it is lesser than threshold, we will make our found to be true and we will break from here. And yeah, after completing this loop, we will again check so that we do not continue our iteration for the I part. So if found is true, simply break. Now in the end, we are again checking this thing. If we found a square which has a sum less than equal to threshold, that means this k value is satisfied. Now we need to find if there is more larger k value or not. So we are just moving our low pointer to mid plus 1, but before that we are storing our current k value as our answer. So whatever the mid value is, we are just storing it into our answer and then moving forward. Otherwise, if this k value does not satisfy the threshold condition, then obviously the larger value will not also not satisfy the condition. So we need to pull our k value to more lower value. So what we are doing, we are doing high equal to mid minus 1. After doing this iteration for valid condition, that is low is less than equal to high, whatever answer we get, we are just returning that. Now we will be seeing what is this get sum function. So this get sum function is nothing but what we have seen in the drawing explanation part. So we had drawn some matrix like this. So we were calculating the sum for this particular part. So what we were doing, we were first calculating this entire sum, then we were subtracting this part, and then we are subtracting this part. Now this part is subtracted twice, so we are just adding this part one more number of time. So this is what we are doing. So first we are taking this entire sum x2 comma y2 and adding we are initializing our sum with that. Now we are subtracting these two parts, x1 minus 1 comma y2 and x2 comma y1 minus 1. This we have already understood in the drawing explanation part, so here I am not going into much more details. Now also we need to check these conditions as well, whether our x1 is greater than 0 or not. Then only we will be able to check this particular part, otherwise it will go out of bounds. Same for here also. So after subtracting these two parts, we know that we have actually subtracted this yellow part 2 number of times, so we need to add this one more number of time to balance this out. So we are just adding this x1 minus 1 comma y1 minus 1 to our sum to balance our sum out. Now also here also we will check this condition, whether this x1 and y1 both are greater than 0 or not. Then only this will be valid values, otherwise it will go out of bound. In the end we are just returning the sum. So this is how, with the help of prefix sum and binary search, we are solving this particular problem. So I hope you understand this problem and the solution as well. So yeah, thank you for watching.